Alright, so what I want to do in this video is introduce the product rule and how to find the formula for the product rule. Right, we can easily memorize a formula, but where does it come from and how do we even get there in the first place? So a good way to start is by the definition of the derivative, right? The formal definition, where it's the limit of the quotient, difference quotient. So our problem here is, how do we even express a product in terms of one function? That's kind of weird, right? We can just do, let's say we have a term here and we have a term, another different one here, right? And we want to multiply them together. That's what we want to express. So the way we do that is by introducing two functions, a and b. I'm going to use a and b just to help us. This is how we express a product as one function. A product of two functions is equal to the function overall f, right? So we're going to input this part into our f of x, right? So f of x plus h is simply just a of x plus h times b of x plus h, right? Not too bad. Not too bad. Alright, so here's where all the, I guess, algebra calculus happens. A lot of algebra thinking, and the calculus just comes at the end. It just happens to be. It is kind of surprising how they even formulated this product rule. So let's begin. The limit, I'm just going to plug in what we know. It is now the limit of a of x plus h, b of x plus h, right? Minus a of x, b of x times b of x, right? I'm just going to put the multiplication symbol like that, right? Not a difficult step. But the problem here is, where do we continue and how on earth do we continue, right? Because we can't, like, do anything. We can't do anything. Well, I guess the genius of the product rule is that people found a way to actually make it work. And that's kind of interesting. They had to be really creative. And how creative did they have to be? Let's see. I'll show you. So I'll stop writing it here. What they did was they introduced a term. They introduced it into the product rule. Or into the, sorry, not the product rule, the derivative formula. They introduced this thing, a of x plus h, b of x. That's kind of weird. We can't just subtract the term and then it's not the same anymore, right? If we just move a term, it's not the same. However, what they did was they immediately added the opposite of it, right? The positive version. Right, so these two would cancel out and you're left back at this step, right? So this was a kind of creative step they took, which is actually really helpful because it led them to the product rule. So where do we go from here? What I'm going to do is split it in such a way, because we can split fractions, right? Because the common denominator is h. So let me do that. Limit as h approaches 0 of a of x plus h, b of x plus h, minus a of x plus h, b of x plus h. That's how I'm going to split it. This is the first fraction. And then we're going to add, and then I'm going to use the limit property, right? We can just do, instead of the limit of the whole thing, you can just do the limit of the two terms of a sum. So I'm just going to copy the rest. And now we have something interesting here. This introduction of a new term allowed us to do something that wasn't possible before. Notice with this first term that there are similarities in factors, right? These two. What we can do with these two factors is factor it out, right? Limit as h approaches 0 of a of x plus h. That's the term we factor out, so kind of like reverse distributive property is what I like to think about it. And I'm going to write it in such a way, maybe you recognize it immediately, maybe you don't, but I'll point it out once we get to that step. Maybe you do. Think about what the formula of the derivative is. So we're going to factor out b of x because that's the common factor in this term, or in this pair. And And then something else also emerges. Something kind of interesting too. Maybe you still don't see it, but look at the term that's still left in the parentheses that we, not the a of x plus h, but the other term. That kind of looks familiar. I'm going to scroll down. This looks like, if I were to look at only this part here, let me highlight it. This part and this part looks like a derivative formula, doesn't it? And we're taking the limit, right? We're taking the limit. The limits, let me box them. In fact, this is actually what the derivative formula is, right? This is just, now we can just see this limit actually just evaluates to the derivative of b. And then this also evaluates to the derivative of a. So now we can just simply plug in h at this point because we already know what this is. So what we're left with is a of x plus 0, which is just a of x, times the derivative of b, plus we have b times the derivative of a. And there it is. That is the, this is the, so let me move it somewhere really quickly. Let me move it over here. This is what it is. So in summary, the derivative, so given that f of x is equal to a of x times b of x, the derivative of f with respect to x is this. This is the formula. You take the derivative of one and keep the other the same, you multiply them together, and then you do the switch, the flip-flop of it. You want to take the derivative of the other and keep the first one the same. Okay? So this is the idea of the product rule. It's an interesting derivation, right? We had to introduce a weird term that made no sense in the beginning, but it allowed us to do a lot at the same time. So that's all for this video, and next video we'll be doing some examples. So